Salam all. So this is an age-old question of whether the electron is a particle or a wave. And the short answer is it depends on whether you're looking at it or not, or whether you're measuring it or not. So what we say is that, or what we've noticed, I should say, as scientists, is that when we've measured the electron or incoming light rays that contain a series of electrons, those are particles in space, right? And they can be quantified. Yet, if we didn't measure them, they behaved very much like a wave in the sense that they diffract like a wave. They interfere like waves do. They show diffraction and interference patterns like waves do. So that moment in time, if you capture or measure an electron and you look at its start point, that's a particle event, and you look at its end point, that's another particle event. Those two are particle events, but in between the start and the finish, these electrons appear to move like waves do. So in between these two interactions, it's going to behave like a wave. And it's not the physical wave that you might be thinking of right now, like a water wave or a wind wave. It's more of a probability wave where the electron is likely to be from its start to its finish. So if you think about it like fog, if there's an area of thick fog, there's a high probability that the electron is traveling in that path or is around that path. And if it's thinner fog, then it's highly unlikely that it is there. But it's not a physical type wave. It's really more of just a probability wave. So is it a bit confusing? Yes, but quantum mechanics is a little bit confusing. And, spoiler alert, it's not just light or electrons that have wave nature. Every single particle in the universe, according to quantum mechanics, has that wave nature. Just the bigger the object is, the harder that waveform is going to be able to detect. And that's based on a formula, which we'll get into later. Thanks for listening, guys.